So we're trying to solve this quadratic equation by completing the square. And part of you might be feeling cocky and saying, well, I could use the techniques in chapter 8 to factor this equation and solve for x, right? And so if we're looking at it, we're saying, is the first term a perfect square, right? Because we're trying to use perfect square trinomials. Yes, it is. Is the last term a perfect square? Yes, it is, right? But is the second term a times 2 times a times b? 2 times x times 2 is 4x. So no, this second term, we cannot use perfect square trinomials to factor this. And then another part of you would be like, okay, well, I could use my x method. And so let's go ahead and draw our x, and we're going to put a times c up at the top, right? 1 times 4. And then we're going to put our b down at the bottom. And now we're looking for our factor 1 and our factor 2, right? And so if you look, there are no two factors that multiply to 4 and add to 16. All right? You just can't find them. All right? So in some cases, completing the square is the only option, like this one here. Well, the only option we've learned about. So to start out, we need it in the form ax squared plus bx is equal to c. That's what we need it as. So to get that started, we're going to subtract 4 from both sides. And we'll be left with x squared plus 16x is equal to negative 4. All right. So our a and our b, our a is 1 and our b is even, right? So perfect candidate. Let's see what we need to add to both sides of the equal sign to complete the perfect square trinomial. It would be b over 2 squared. And so our b is 16. Right? So it's going to equal to 16 divided by 2 squared. That's going to be 8 squared. So it's going to be 64 is what we need to add to both sides of the equal sign to make the left side a perfect square trinomial. So let's do that. We'll say x squared plus 16x plus 64 is equal to negative 4 plus 64. What did I do? I found out what I needed to add to complete the perfect square trinomial, and then I added it to both sides of the equal sign. All right. And so now we check, is this a perfect square trinomial? Right? Is the first term a perfect square? Yes. Is this last term a perfect square? Yes. Right? So our a is equal to x. Our b is equal to 8. Is the center term 2 times a times b? 2 times a, 2x, times b is 16x. Yes, it is. Perfect square trinomial. All right. So we can go ahead and write our answer down, our factors down as a plus, since this second term is positive, we're going to put a plus 8 squared. All right, we've used perfect square trinomials to factor the left side of the equal sign, and that's going to equal to 60. All right, so now we need to solve for x, right? And so to do that, we need to take the square root of both sides. On the left side of the equal sign, we have two factors of x plus 8, because x plus 8 squared is x plus 8 times x plus 8. So we can pull out an x plus 8 on the left side of the equal sign. And so that's going to equal to square root of 60. And so what is the square root of 60? Well, we can go ahead and simplify it, but maybe we could save that for later, right? All right. So to solve for x, we're going to subtract x from both sides of the equal sign. So what we'll end up with is x is equal to negative 8 plus the square root of 60. And now why don't we simplify that square root 60, right? So we have the square root of 60 is equal to the square root of 2. That makes 60 divided by 2 is 30 times 2 times 15. Right? So 2 times 2 is 4 times 15 is 60. Yeah, I think that's right. And so 5 doesn't factor. I mean, 5 can factor down to 3 times 5, right? But we can't pull out a 3 or a 5 because there's two of them. We don't have a pair of any factors. So here we have a pair of 2's, so we can pull that out. So square root 60 simplifies to 2 square root 15. So let's go ahead and use that here. X is equal to negative 8 plus 2 square root 15. Take that as our final answer. Alternatively, you could drop this in a calculator, but this is I'm very happy with this answer here. So x is equal to negative 8 plus 2 square root